How to manage rebar placement on site. Have you ever walked into a construction site and seen a chaotic pile of steel bars, all tangled, mismatched, and confusing? That's what happens when rebar placement isn't properly managed. Rebar, or reinforcement steel, is the hidden backbone of concrete, and managing its placement on site is one of the most critical responsibilities of a site engineer. In this video, we'll go through exactly how to manage rebar placement step by step, from preparation to inspection, so your concrete structures stay strong, durable, and perfectly aligned. Welcome to Rigid Academy, the home for civil engineers and construction professionals who want to level up their site management skills. Today's topic, rebar placement, might look simple, but it's where most site errors begin. Misplaced bars, incorrect lap lengths, missing chairs, or poor spacing, all these small mistakes can lead to cracks, deflection, or even failure in reinforced concrete structures. By the end of this video, you'll know how to plan, check, and control the entire rebar process like a pro, whether it's a footing, slab, beam, or column. Step 1. Understand the rebar drawings. The first step to managing rebar placement is knowing your drawings. Before any bar is cut or bent, study the reinforcement drawings carefully. Pay attention to the bar diameters and spacing, lap and anchorage lengths, cover requirements, especially different covers for footing, beam, column, and slab, bar marks, and bending schedules. A good practice is to highlight each bar type with different colors on a printed drawing. This helps the team visually understand where each bar goes. Remember, one wrong interpretation at this stage can lead to hundreds of wrongly placed bars later. Step 2. Verify material quality and bar bending. Before starting placement, check that all rebar delivered to the site matches the specifications. Confirm the following: the grade of steel, for example, FE 500 or FE 415. The bar diameter with a vernier caliper. The surface condition, it should be clean, free from rust, oil, or paint. Then verify the bending process. All bars should be bent according to the approved bar bending schedule using the right radius and angle. Never allow workers to bend bars manually using hammers. Use mechanical benders or hydraulic machines for accuracy. If you're managing a large site, tag each bundle of bars with bar mark numbers and lengths. This reduces confusion during placement. Step 3. Prepare the concrete surface and marking. Before you place rebar, ensure that the surface where reinforcement will be laid is properly cleaned. Remove debris, oil, and standing water. Next, mark reference lines for center lines and cover blocks using chalk or marking paint. In foundations, columns, and beams, layout accuracy is everything. Use the reference drawings to mark the exact grid lines, ensuring the reinforcement is positioned in the right location. For slabs, use rebar chairs and spacers to maintain uniform cover. For vertical members like columns, ensure alignment with plumb bob or laser levels. This step might feel time-consuming, but trust me, it's what separates a professional site from a messy one. Step 4. Placement of main reinforcement. Now it's time for the actual placement. Follow the sequence given in the drawings. Start with bottom reinforcement. Place distribution or secondary bars, then fix the top reinforcement layer. Use proper spacers and cover blocks to maintain the designed cover thickness. Covers are not just numbers, they protect the rebar from corrosion and fire. Typical cover values are 25 millimeters for slabs, 40 millimeters for beams, 50 millimeters for columns, 75 millimeters for footings. Also ensure bars are tied properly with annealed binding wire, not loosely, but tight enough to prevent movement during concreting. Step 5. Lapping, splicing, and anchorage. Laps and splices are critical for structural performance. Check that lap lengths follow design specifications, generally 50 times the bar diameter for tension members. Never place laps at the same section for multiple bars, stagger them to maintain structural continuity. For columns, laps should be within the central 1/3 of the height. For beams, place laps near the point of minimum stress, usually away from supports. Anchorage should be properly bent, hooks, bends, or mechanical couplers, as per design. If you're using couplers, check that the threading is clean and tight. And always remember to mark and record lap locations for inspection. Step 6. Check alignment and spacing. Once all reinforcement is in place, conduct a detailed inspection before concreting. Here's what to check. Bar spacing using a steel tape. Cover distance using cover meters or feeler gauges. Verticality and alignment in columns. Straightness and continuity in beams and slabs. Also ensure that bars are tied in place. They shouldn't move when stepped on. For slabs and beams, use support bars or chairs to maintain the top layer height during concreting. A well-placed reinforcement cage should feel stable and symmetrical when viewed from above. Step 7. Inspection and approval before pour. Before pouring concrete, call for inspection. Usually, your site engineer, structural consultant, or quality control engineer must approve the reinforcement. They'll check drawing compliance, bar counts and bends, lap and cover distances, cleanliness of reinforcement. Only after this inspection should concreting begin. Skipping this step is one of the most common mistakes that lead to rework later. Common mistakes and how to avoid them. Let's go through the mistakes most engineers make on site. Incorrect cover blocks. Using wooden or brick pieces instead of proper concrete cover blocks causes corrosion later. Improper bar bending. Sharp or inconsistent bends can reduce bar strength. Missing ties leads to displacement during concrete pour. Unstaggered laps creates weak zones. Dirty rebar surface, oil, rust, or dust prevents bonding with concrete. Skipping inspection. No visual check means hidden errors remain inside concrete forever. To avoid these, make a checklist and verify each item before every pour. Always document your inspection with photos and notes. It helps during audits or disputes. Pro tips for site engineers. Here are a few expert tips to make your rebar management smoother. Always keep a bar bending schedule (BBS) updated and signed. Mark bar diameters and positions using color-coded tags. Maintain a small site store for storing spare bars, chairs, and cover blocks. If rebar gets wet in rain, clean and dry it before use. Educate your workers. A 5-minute briefing can prevent a 5-hour mistake. Managing rebar placement isn't just about placing steel. It's about ensuring the future safety of your structure. A good site engineer treats every bar, every lap, and every tie as part of a bigger system. One that carries loads, protects lives, and defines the strength of the entire building. If you found this guide useful, don't forget to like this video, subscribe to Rigid Academy, and share it with your fellow engineers. Let's keep building smarter, safer, and stronger structures together.